Hello children, welcome back to my channel. Now I am dealing with ninth class quadrilaterals, exercise 8.3. In this sixth problem, 5 sums I have already done. Sixth one, see this is the figure given to you. ABCD is a parallelogram and AP and CQ. See this is AP, this is CQ are perpendiculars drawn on BC, BD. Show the triangle APB. APB is congruent to triangle CQD. So let us see. In triangle APB and triangle CQD. In these two triangles, AB is equal to CD. Why? Because they are the opposite sides of parallelogram. So they are equal. And angle P is equal to angle Q. They are 90 degrees given. They have given to us. And also, let me call this as angle 1 and this as angle 2. Angle 1, first in APB I should write angle 2 is equal to angle 1. Why? They are alternate angles. Therefore, triangle APB is congruent to triangle CQD basing on angle side property. Two triangles are congruent. So the first bit I have proved. Now second bit. What is the second bit? AP is equal to CQ. Triangle APB is congruent to triangle CQD. This is just now proved. We have proved just now. So when two triangles are congruent, then their corresponding sides are equal. So AP is equal to CQ. This is the proof, children. Please note it down. Listen. ABCD is a parallelogram they have given. AP and CQ are the perpendiculars to BD. So we need to prove that triangle APB is congruent to triangle CQD. See, AP is in these two triangles. AB is equal to CD because they are opposite sides of the parallelogram. And angle P is equal to angle Q. They are 90 degrees that is given to us because they said they are perpendicular. Perpendiculars means 90 degrees. And angle 2, see, in APB, this is angle 2, is equal to angle 1. Why? They are the alternate angles. These two are parallel lines because ABCD is a parallelogram. So these two becomes alternate angles as BD is a transversal. So yeah, angle 2 is equal to angle 1. They are alternate angles. So the triangle APB is congruent to triangle CQD basing on angle side property. So when these two triangles are congruent, definitely their sides are equal, corresponding sides. Please note it down, children. Now seventh sum, children. In triangle ABC, triangle ABC and triangle DEF, you can see, children. Triangle ABC, this is ABC and DEF. AB is parallel to DE. AB is equal to DE. These two are parallel and these two are equal. And BC is equal to EF and BC is parallel to EF. Now, what is given? Let me write. In triangle ABC and triangle DEF, AB is equal to DE. AB is parallel to DE. And what else they have given? BC is equal to EF. And BC is parallel to EF. So, RTP. What is RTP? First one, ABED is a parallelogram. And second one, BCFE is a parallelogram. Third one, AC is equal to DF. And fourth one, triangle ABC is congruent to triangle DEF. So let us see the proof. Let us go to the first one. AB is parallel to DE. This is given. And AB is equal to DE. This is also given. So what you can say? Opposite sides are parallel and equal. So if opposite sides are parallel and opposite sides are equal, we can say that A, B, E, D, A, B, E, D is a parallelogram. So the first bit we have proved in this way. Now let us go to the second bit. Second bit. BC is equal to EF and BC is parallel to EF. BC is parallel to EF. What is this? This is also given to us. They have given to us. So again the same thing. Opposite sides are parallel and equal. See here children. BC is equal to EF. BC is parallel to EF. Therefore, what you can say? BCFE. BCFE is a parallelogram. So this is the second bit proof. Now third bit, we need to prove that AC is equal to DF. To prove that AC is equal to DF, first let me take these two parallelograms. We know that AD is equal to BE. BE, this is given to us. AD is equal to BE, or let me take ABED. I'll take it like this. ABED is a parallelogram. This we have just now proved. Therefore, what you can say? AD is parallel to BE. AD is parallel to BE. Again, BCEF, this let me take it as first equation. BCEF, you may not see it, I'll do it here. BCEF is a parallelogram we have just now proved. We have just now proved BCEF is a parallelogram. Therefore, BE is parallel to CF. BE is parallel to CF. This is second one. So, from 1 and 2, what we can say? AD is parallel to EF. CF. See children, AD is parallel to BE. BE is parallel to CF. So, AD is parallel to CF. Similarly, we can prove that AD is equal to CF. Therefore, what we can say? ACDF is also a parallelogram. ACDF is a parallelogram. If ACDF is a parallelogram, ACDF is a parallelogram, AC will be equal to DF. So this is how the third bit we can prove. Now fourth bit, triangle ABC is congruent to triangle DEF. So in triangle ABC and triangle DEF, in these two triangles, AB is equal to DE. Opposite sides of parallelogram. AB is equal to DE. Similarly, BC is equal to EF. Same reason. And also AC is equal to DF. For the same reason, opposite sides of parallelogram. AC is equal to DF. Therefore, triangle ABC is congruent to triangle DEF basing on side property. So this is how you can prove, children. Once again, let me explain you. In triangle ABC, see, they have given two triangles in which AB is parallel to DE and AB is equal to DE, and BC is parallel to EF, BC is equal to EF. Now we need to prove that ABED is a parallelogram, BCFE is a parallelogram, and third bit AC is equal to DF, and triangle ABC is congruent to triangle DEF. These are the properties which we need to prove. So, what is given in triangle ABC and TF? AB is parallel to DE, AB is equal to DE, BC is parallel to EF, BC is equal to EF. What is RTP? AB ED is a parallelogram. Second bit BCFE is a parallelogram. Third bit AC is equal to DF. Fourth bit triangle ABC is congruent to triangle DEF. So one by one if you take, see AD is parallel to BE. They have given uh, AB is parallel to ED, they have given. AB is equal to DE, they have given. So opposite sides are equal and parallel. So definitely ABED is a parallelogram. Similarly, BCEF. BC is equal to EF, they have given. BC is parallel to EF, they have given. So BCEF is a parallelogram. So here also opposite sides are parallel and equal. So BCEF is a parallelogram. Now the next one we need to prove AC is equal to DF. So in this what we can say, ABED is a parallelogram. When ABED is a parallelogram, then so ABED is a parallelogram. So AD is parallel to B. Similarly, BCEF is a parallelogram. So BE is parallel to CF. Similarly, even parallelogram, so AD is equal to BE, BE is equal to CF. So what we can say, AC is also the ACDF or ACFD. I can say ACFD. In an order, if you write ACFD is a parallelogram. Opposite sides are equal, opposite sides are parallel, we have said. So we can say that here we can say AD is equal to CF. So ACFD is a parallelogram. When ACFD is a parallelogram, we can say that opposites AC and DF are also opposite sides. So AC is equal to DF. We can prove that first one we have already proved. This one, third one we have proved. Now in this triangle ABC and triangle DEF, AB is equal to DE, opposite sides of parallelogram. AC is equal to DF, they are also opposite sides of parallelogram. BC is equal to EF, that is also given to us. So these two triangles are congruent basing on side property. Please note it down. Now, eighth problem, children. In this, ABCD is a parallelogram. ABCD is a parallelogram, and AC and BD are diagonals. They are intersecting at a point O. P and Q are points of trisection. That means P divides BD into three equal parts. That means BP is one third of BD. Similarly, Q trisects. So DQ is one third of DB. Now we need to prove that CQ is parallel to AP and AC bisects CQ. So let us see. Let us take in triangle uh, CDQ and triangle APB. CDQ ABP, I'll write ABP in triangle ABP. In these two triangles, CD is equal to AB. Why? They are the opposite sides of parallelogram. So they are equal. And also, let me take this is triangle APB and this is triangle CDQ. So let me take this as angle 1, this as angle 2. Angle 2 for CDQ, angle 2 is equal to angle 1. They are alternate angles. Because these two are parallel, this becomes the transversal, these two are alternate angles. And CQ is equal to one third of BD. This is given. And also BP is also one third of BD. This is also given to us. Therefore, CQ is equal to BP. CQ is equal to BP. Therefore, what you can say, triangle CDQ is congruent to triangle ABP basing on side property. When these two are congruent figures, what you can say, CQ is equal to AP. Okay, let us consider this as the first point which we have got, first equation or first proof that we have done. Now, the next one, similarly, we can prove that in the same way, when we have proved CQ is equal to AP, we can prove AQ is equal to CP. AQ is equal to CP because we can take these two triangles and we can say that they are also uh, congruent basing on the same procedure. When they are congruent, when AQ is equal to CP, this is the second one. So what is that in APCQ? In APCQ, what we have got, AP is equal to CQ. AP is equal to CQ. This is just now we have proved. First statement which we have proved. And AQ is equal to CP. AQ is equal to CP. This is also we have proved. Proved in the sense we have, just like the first one we can do. Second event. Therefore, what you can say, APCQ is a parallelogram. The reason is opposite sides are equal. When opposite sides are equal, it is a parallelogram. So when you could prove that APCQ is a parallelogram, then definitely we can say that CQ is parallel to AP. So the first one we have proved. And the second bit is, what is the other one they have said? AC bisects PQ. When APCQ is a parallelogram, then PQ and AC PQ and AC are diagonals. PQ and AC are diagonals. Therefore, diagonals of parallelogram bisect each other. Therefore, what you can say, AC bisects PQ. This is what the proof that we have proved, children, in this problem. See it, children. What is given? A, B, C, D is a parallelogram and points they intersect at O. AD and AC and BD are diagonals intersect at O. P and Q are the points of trisection of BD. They divide BD into three equal parts. Now we need to prove that CQ is parallel to AP. So how will you prove? See, in triangle CDQ and in triangle ABP, AB and CD, these two are equal because they are opposite sides of parallelogram, and angle 2 is equal to angle 1, they are alternate angles. And CQ, what is CQ? CQ is nothing but one third of BD they have given to us, and BP is also one third of BD. So we can say RHS are same, LHS are equal. CQ is equal to BP. So triangle CDQ is congruent to triangle ABP basing on side angle side property. We can say that they are equal side angle side, this side DP, DQ and BP. So when these two triangles are congruent, CQ is equal to AP, we can prove. Similarly, if you take triangle ADQ and BCP, same proof, opposite sides are equal and DQ is equal to BQ and alternate angle. This angle is equal to this angle, alternate. Same proof we will write. That is why I wrote similarly. We can prove that AQ is equal to CP. So in APCQ, we could prove that AP is equal to CQ and AQ is equal to CP. That means what? Opposite sides are equal. So we can say that APCQ is a parallelogram. APCQ is a parallelogram. If it is a parallelogram, definitely CQ is parallel to AP. That we have proved. And the next thing we need to prove, AC bisects PQ. See, when APCQ is a parallelogram, PQ and AC are the diagonals. PQ and AC are diagonals. So the property of parallelogram is diagonals bisect each other. Therefore, AC bisects PQ. When AC bisects, this is what they have asked you to prove. We have proved, children. Please note it down. Now, children, ninth problem. ABCD is a square. EFGH are the midpoints of AB, BC, CD, and DA respectively, such that AE is equal to BF is equal to CG is equal to DH. Prove that EFGH is a square. So, without drawing the figure, we cannot understand. So, let us draw the figure first. So, what did they say? A, B, C, D is a square. E is the midpoint of AB, F is the midpoint of BC, G is the midpoint of CD, and H is the midpoint of DA. Now, join this. Apart from this, what did they say? AE is equal to BF is equal to CG is equal to DH. They have. Now we need to prove that EFGH is a is a square we need to prove. Now let us join AC. This I will, while explaining, I will do children otherwise. So what is given? A, B, C, D is a square. And also they have given that E is the midpoint of AB. F is the midpoint of BC. G is the midpoint of CD. H is the midpoint of AD. This is given to us. Now, what is RTP? We need to prove that EFGH is a square. This we need to prove. Now, construction here, children. Join AC. So, when I join AC, proof. I can say that this is a triangle in triangle ADC. GH is parallel to AC and GH is equal to half of AC. This is what the theorem which we have learned. In a triangle, if two midpoints are joined, midpoints of two sides are joined, then the line is parallel to third side and it is half of third side. So GH is half of AC. Similarly, we can prove that in the same way we can prove that EF is half of AC. EF is half of AC. Therefore, what you can say? GH is equal to EF. We can say that GH and EF are same. Then same way, similarly, we can prove that in the same way, we can prove that EH is equal to FG. EH is equal to FG. So we can say that therefore in quadrilateral EFGH, EFGH, EF is equal to FG is equal to GH. FG is equal to GH is equal to HE. So what we can prove? We have proved that all these sides are equal. Now let us take, see, when sides are equal, it might be a rhombus or it might be a square. So we need to prove that it is a square. We need to prove that it is a square means this angle E 90 degrees, so that we have to prove. So to prove that angle E 90 degrees, let us take triangle AHE and BEF. First, when you talk about in triangle AHE, in triangle AHE, in this triangle AHE, angle A is equal to 90 degrees. This is given to us because ABCD is a square. It is 90 degrees. And also AH, what they have given? AE is equal to, see children, AE is equal to BF. AE is equal to BF and BF is equal to CG. CG is equal to DH they have given. But DH is equal to AH, no, these two are equal, no, because H is the midpoint. So I can say that AE is equal to AH is equal to AE, I can say. AH is equal to AE. Why is the reason? Because we have AE is equal to DH, and DH I can write it here because AE is equal to DH and DH is equal to DH is equal to AH. Because of the reason, I can say that AE is equal to AH or AH is equal to AE. Okay, so when AE and AH are equal means, let me call this as angle 1 and this as angle 2. So I can say that angle 1 is equal to angle 2 because it is 90 degrees means 45 and 45 makes 90. One more 90 we need. So similarly, let me take this as angle 3 and angle 4. So similarly, in triangle EBF, angle 3 will be equal to angle 4. Angle 3 is equal to angle 4. Now, we know that angle 2 plus, let me call this as angle 5. Angle 2 plus angle 5 plus angle 3 is equal to 180 degrees. They are linear angles. See, angle 2 plus angle 5 plus angle 3, 180 degrees because they are linear angles. Also, what you can say, angle 1 plus angle 2 plus angle 3 plus angle 4 also is equal to 180 degrees because this is these two and these two sum is also 180 degrees. That means we can say that this can also be written as angle 1 is equal to angle 2, I said no. So instead of angle 1, I'll write angle 2 plus angle 2 plus instead of angle 4 also I'll write angle 3 is equal to 180 degrees. That means 2 times of angle 2 plus 2 times of angle 3 is equal to 180 degrees. So let me see the space for completing my problem. I'll do it here actually. I'll do it here. So here I think this I can write completely. This is nothing but 2 times of angle 2 plus angle 3 is 180 degrees. That means angle 2 plus angle 3 is 180 by 2, that is 90 degrees. Angle 2 plus angle 3 is 90 degrees. And we have written that angle 2 plus angle 5 plus angle 3 is 180 degrees. In this, angle 2 plus angle 3 is 90. 90 degrees plus angle 5 is 180 degrees. So, angle 5 is 180 minus 90 degrees. That is, angle 5 is 90 degrees. We could prove that angle 5 is 90 degrees. So, what we can say? Therefore, in EFGH, all sides are equal and angle, what is that, angle E is equal to 90 degrees. Therefore, EFGH is a square. This is the proof of it, children. So, please note it down once again. See, they have given ABCD as a square. EFGH are midpoints of AB, BC, CD, and AD. We need to prove that EFGH is a square. So, to prove that construction, join AC. When you are joining AC, see, in triangle AC, ACD, these are the midpoints. So GH is equal to is half of AC and GH is parallel to AC based on the theorem. So GH is parallel to GS is half of AC. Similarly, EF is half of AC. We can prove that means GH is equal to EF. Similarly, we can prove that EH is equal to GF. That means HEFG. That is nothing but EFGH. It is in quadrilateral, all the four sides are equal. We have proved. If all the four sides are equal, it might be a rhombus or it might be a square. If you want to prove that it is a square, any one of the angles is 90 degrees, we have to prove. So I have taken in triangle AHE. See, angle A is 90 degrees because it is square 90 degrees, and AE is equal to AH. Why? Because AE is EF, they said, EF is CG, CG is DH, they said, but DH is equal to AH. So these two are equal. So when these two are equal, what we can say? Angle 1 is equal to angle 2. Similarly, angle 3 is equal to angle 4. So angle 2 plus angle 5 plus angle 3 is 180 because they are linear pair. And also we know that angle 1 plus angle 2 plus angle 3 plus angle 4 is also 180 degrees because these two sum is 90, these two sum is 90. That means 2 times of angle 2 plus 2 times of angle 3. What I did, instead of angle 1, I took angle 3. Instead of angle 4 also, I took angle 3. So instead of angle 1, I took angle 2. Instead of angle 4, I took angle 3. So 2 times of angle 2 plus 2 times of angle 3 is 180 degrees. That means angle 2 plus angle 3 is 90. When these two angles are 90 degrees, definitely angle 5 is 90 degrees. So in this quadrilateral, we have proved that all sides are equal and one of the angle is 90 degrees. So we can say that it is a square. EFGH is a square. So please note it down, children. With this, I am going to conclude my topic. In the next class, I will be doing the next part.